scheduling. The management of all operations, such as system development and product production, so that they proceed as planned is known as scheduling. Since the final objectives of scheduling are to keep costs within budget and to ensure that products are delivered on time, when the problems of business operations occur, they must be solved by appropriate countermeasures. Here, we will provide an overview of one effective method of schedule management, the creation of arrow diagrams. (1) Arrow diagrams. Using arrow diagrams for scheduling, working procedures and reciprocal relationships become very clear. In addition, these diagrams clarify critical work processes, as well as enable the easy calculation of the duration for the entire operation. Arrow diagrams contain the following elements. A. Nodes. In arrow diagrams, activities are represented by arrows and nodes of activities are shown as circles, i.e., the points at which one activity is followed by another. Since the relationship between predecessor activity and successor activity is shown by the connecting arrows, arrows and nodes are connected together in activity order. B. Dummy activity. A name is assigned to each arrow and the standard number of days required are also written. Nodes are assigned sequence numbers. Node numbers must be smaller at their starting node than at their ending node. In addition, two nodes can only be connected by one arrow. Thus, when two activities with the same starting and ending nodes take place at the same time, a dummy activity is inserted and represented by dotted lines. Dummy activities only show the connection to the activity and the number of required hours is set to 0. For example, when activities P and Q are run in parallel as shown, a dummy activity is inserted as in the image on the right. In this instance, activity R cannot be started unless both activity P and activity Q are completed. Although in arrow diagrams there is no limit to the number of activities that can have the same starting or ending nodes, there is a rule that the next activity cannot be started unless all of the preceding activities are completed. In addition, there are no limitations to the extent that activities branch out in midstream. However, there can only be one starting node and one ending node to the overall project. Next, the following times, or number of days, are managed using arrow diagrams. Earliest node times. Latest node times. Float. C. Earliest node time. The earliest node time, hereafter, abbreviated as ET, is obtained by performing calculations working from left to right. In fact, by starting from the starting time of the project, ET is the earliest time that an activity, whose starting node, can begin when all activities follow the standard time required. Try to calculate the ET in the following diagram. In the illustration, in each of the rectangular boxes near the nodes, the upper box shows the ET. Although ET represents the total required time of predecessor activities, where there are two or more predecessor activities, the one with the largest value is used. D. Latest node time, hereafter, abbreviated as LT. The latest node time is obtained by performing calculations backwards from right to left. In fact, LT is the latest possible starting time for each activity, which is reached by subtracting required times for each activity from the project ending time. Although LT represents the total required time of successor activities, when there are two or more successor activities, the one with the smallest value is taken. A calculation of LT is shown in the diagram below. In each of the rectangular boxes near the nodes, the lower box shows the LT. E. Float in critical path. The time that results when ET is subtracted from LT is called float. When there is float, it means that there is some time flexibility, or slack, for the activity which ends at the node. For example, as can be seen in the diagram, there is float of 1 day for the activity G from node 3 to node 6. This means that even if the activity G can be delayed 1 day, from the 6th to 7th day, it will not affect any activities which follow. E. Float in critical path. The time that results when ET is subtracted from LT is called float. When there is float, it means that there is some time flexibility, or slack, for the activity which ends at the node. For example, as can be seen in the diagram, there is float of 1 day for the activity G from node 3 to node 6. This means that even if the activity G can be delayed 1 day, from the 6th to 7th day, it will not affect any activities which follow. A path connecting nodes with zero float is called a critical path. Since a critical path is a path which connects activities without any slack, it is necessary to focus management on the activities in that path. In scheduling, the detection of critical paths is extremely important. To this point, we have reviewed the earliest node time and latest node time for each node. However, it is important to manage required time for each individual activity. The time units that must be addressed include the earliest starting time, latest starting time, earliest finish time, latest finish time, and float.